When NASA released the new Perihelion data for 3I Atlas, something didn't add up. Instead of heating up near the Sun, the object's temperature dropped. Instead of shedding gas and dust, it sealed itself tight. Its reflectivity doubled. Its magnetic field began to pulse, perfectly rhythmic, like a machine. No comet, asteroid, or fragment in recorded history behaves like this. Telescopes across 3 continents confirmed the same impossible pattern. 3I Atlas wasn't reacting to solar radiation, it was responding to it. NASA called it a controlled reaction. But controlled by what? Or by whom? Tonight, we break down the data that has divided every space agency on Earth and reveal why this single moment near the Sun might prove 3I Atlas isn't just a comet, but something else entirely. For decades, astronomers have studied comets as predictable visitors, icy remnants from the birth of the solar system that flare into brilliance when they near the Sun. The rules are simple. Heat rises, ice vaporizes, a glowing coma forms, and gas jets push the comet slightly off course. Every comet follows this dance. That's what scientists expected when 3I Atlas reached its closest point to the Sun, known as Perihelion, on October 29th. Observatories from Hawaii to Madrid waited for the familiar brightening, the roaring activity that marks a comet's climax. But instead of bursting into light, it dimmed. Within just 6 hours, its brightness collapsed by nearly 40%. The very moment it should have been most alive, 3I Atlas went silent, like a machine powering down in the face of too much energy. And that was only the beginning. In the hours after perihelion, telescopes flooded with confusion. The Solar Dynamics Observatory, the European Solar Orbiter, and dozens of ground arrays all reported the same impossible thing. No outgassing, no tail, no heat spike. Instead, the coma, the glowing halo that should have expanded, contracted. Spectral readings showed a sudden drop in vaporized ice and dust. It was as if the object had thrown up invisible shields, cutting itself off from the Sun's radiation. NASA scientists ran simulations, trying to explain the silence. Nothing fit. Even the most extreme thermal models couldn't reproduce a total shutdown at such proximity. One researcher described it bluntly. It's like it knew it was getting too hot and decided to turn off. The universe doesn't make decisions. Yet somehow, 3I Atlas did. When the silence couldn't be explained, scientists turned to spectroscopy, breaking light into its chemical fingerprints. At first, the readings seemed normal. Traces of water vapor, carbon monoxide, carbon dioxide, and standard comet chemistry. But as 3I Atlas reached perihelion, those familiar signals began to fade, replaced by something new. Strange molecular lines appeared, patterns that matched no known substance in any laboratory database. Dr. Robert Work at the University of Hawaii analyzed the spectra for 12 straight hours. He compared every asteroid, every comet, every meteorite sample ever recorded. Nothing matched. The data revealed compounds that shouldn't exist, complex hydrocarbons, and nitrogen-bearing molecules that defied chemical stability. Either we're seeing chemistry that doesn't happen in nature, he wrote, or we're seeing something that isn't chemistry at all. And that possibility sent shockwaves through every observatory on Earth. The next anomaly came from the infrared telescopes. They measured the heat radiating off 3I Atlas, and what they found broke every known rule of thermodynamics for small bodies in space. Normally, a comet near the Sun develops hotspots, patches that flare brighter, depending on how sunlight hits them. But 3I Atlas showed none. Its entire surface remained at a uniform temperature, varying less than 2 degrees Kelvin across its visible face. That's not how nature behaves. Irregular rocks absorb and radiate heat unevenly. But here, something was balancing it, redistributing energy with mechanical precision. Some suggested rapid rotation. Others whispered of internal heat regulation, the kind used in engineered systems to prevent damage. Whatever it was, it meant one thing. 3I Atlas wasn't just enduring the Sun, It was adapting to it. As if the heat anomaly wasn't enough, the next data set stunned even the skeptics. Within 8 hours of reaching perihelion, 3I Atlas's albedo, its reflectivity, more than doubled. It went from darker than charcoal to nearly as bright as lunar ice. That kind of shift shouldn't happen. A comet's surface can't just change material in a single day. Exposing fresh ice would increase brightness, but it would also increase activity. And yet, 3I Atlas had gone silent. The only explanation was transformation. The surface restructured itself. Some researchers speculated about electrochromic materials, substances that alter reflectivity when exposed to voltage or heat, the kind used in smart windows and spacecraft coatings. If true, this wasn't geological behavior. It was technological. Something on or within 3I Atlas had re-engineered its skin. Then came the readings from NASA's Parker Solar Probe. As it passed within range, its magnetometers detected something completely unexpected, a structured magnetic field surrounding 3I Atlas. Natural comets can generate faint, chaotic fields through ionized gas interactions. But this wasn't faint, and it wasn't chaotic. It was organized. The probe recorded steady oscillations, magnetic pulses repeating every 4.7 seconds with mechanical precision. To produce that kind of pattern, the object would need flowing electric currents or active magnetic control systems. One scientist described it as a heartbeat in space. But rocks don't have heartbeats. If those pulses weren't random, they could represent power generation, communication, or control. Whatever their source, 3I Atlas wasn't just reflecting sunlight anymore, it was sending something back. Would you like to continue to Section 7? The course correction, the impossible 800-kilometer shift, or extend this section with more sensory and dramatic detail before the next reveal? Excellent. Moving deeper into the escalation phase of the scientific speculative narrative, blending factual tone with cinematic suspense. The first to notice was a graduate student at the European Space Operations Center. She compared orbital plots taken just hours apart and froze. 3I Atlas had shifted, not by much in cosmic terms, about 800 kilometers, but it was off trajectory, a move that couldn't be explained by solar pressure, gas release, or gravitational drift. The vector of the change was deliberate, smooth, precise, like a burn from a thruster. When NASA cross-checked with JPL's data, the correction was confirmed. The anomaly had adjusted its own orbit, slowing slightly, as if resisting the sun's pull. A natural body doesn't perform orbital maintenance. Yet, here it was, a silent traveler executing what looked like a controlled maneuver. And that begged a question scientists weren't ready to face. If 3I Atlas moved itself, then who or what gave the command? Less than 24 hours after the orbital shift, the Deep Space Network in Canberra picked up something it shouldn't have. A narrow-band radio emission coming directly from the region around 3I Atlas. The frequency wasn't random. It pulsed in mathematical intervals, 2, 3, 5, 7, 11. The sequence of prime numbers, artificial patterns. Engineers assumed it was a reflection, a terrestrial echo from a distant transmitter. But triangulation confirmed it originated near the object itself. The signal was faint, yet remarkably stable, as if powered by an internal source. For 12 minutes, it held that pattern, then vanished without trace. Radio telescopes scanned the sky for days, but the silence that followed was almost louder than the signal itself. Whatever transmitted that message, it wasn't asking for attention. It was proving it could be heard. The discovery ignited a storm across the global scientific community. In one camp stood the traditionalists, astrophysicists, who insisted every anomaly must have a natural explanation. They proposed exotic theories, magnetic reconnection, plasma harmonics, even quantum interference with solar radiation. But the other camp, quieter, more cautious, began asking a forbidden question. What if 3 Atlas wasn't a rock at all? The pattern of its movements, the thermal regulation, the reflective shift, the pulsing field, taken alone, they might be coincidences. Together, they painted a pattern too deliberate to ignore. Governments classified sections of the data. Civilian observatories were told to redirect their scopes. SETI issued a brief statement, then went silent. The narrative split the world in two, those searching for logic and those beginning to sense intent. For the first time, science couldn't agree on what reality was showing them. Then came the final twist. As 3I Atlas slingshotted around the sun, astronomers expected it to continue outward, to fade into the dark like every other interstellar traveler before it. It didn't. Instead, its course bent again, subtly but undeniably, adjusting into a new vector that leads back toward the inner solar system. That single move defied celestial mechanics. It was as if the object had changed its mind. Simulations show it will pass Earth's orbital path within the next decade, but at a velocity too controlled to be random. Some call it coincidence, others, a maneuver. But one truth remains. Every instrument that has touched 3I Atlas data now carries a question no one can escape. If it's coming back, was it ever just passing through?